Okay, let's do another example here. In this example, we are supposed to find the extreme values of the function f of xy equals x squared plus 2y squared on the circle x squared plus y squared equals 1. Okay, so let's see here. So our constraint is going to be g of x comma y equals 1, where g of xy is x squared plus y squared. Oh, that's written right here. Yes. And we are trying to maximize the function f of xy equals x squared plus 2y squared. Okay, so the first thing I'm going to do, let me add a page below. Okay, so the first thing I'm going to do is just, let me get ready because I know what I need to do. I need to solve delta f equals lambda times delta g. And let's see here. And also need g of xy equal 1. Okay, so my function f is, let's see, it's x squared plus 2y squared. Equals x squared plus 2y squared. So that means that fx is going to be 2x, fy is going to be 4y. So my my gradient is going to be 2x comma 4y. Okay. So I've got 2x comma 4y equals lambda times, I need the gradient of g. So g of xy is x squared plus y squared. And the gradient of g is just going to be 2x, 2y. So we need lambda times 2x comma 2y. Okay, and it's subject to the constraint that x squared plus y squared is equal to 1. So again, I can rewrite this as now 2x equals lambda times 2x, 4y equals lambda times 2y, and x squared plus y squared equals 1. Okay, so now, from the first set of equations here, it looks like, let's see, I'm just going to have 2x minus lambda times 2x equals 0. So I'm going to factor out 2x. 2x times 1 minus lambda equals 0. So that tells me I can divide by 2, right? So x times 1 minus lambda equals 0. So x equals 0 or lambda equals 1. Let's look at the second equation. What information are we gleaning from the second equation? Let's see here. From the second equation, we are saying that 4y minus lambda 2y equals 0. So we can factor out 2y times 2 minus lambda equals 0. And then we can divide by 2. Y times 2 minus lambda equals 0. So this says y equals 0 or lambda equals 2. All right. So now how do we put all this together? Well, it looks like we've got several scenarios here. Either x equals 0. If x equals 0, what happens? Then plugging in, let's see here. If x equals 0, then either, y equals 0 or lambda equals 2. And let's look in here. 0 squared plus y squared equals 1. Oh, wait. So that means that we cannot have y equals 0, right? So it turns out if x is equal to 0, then that means lambda is equal to 2. and y equals plus or minus 1. So our points of interest are 0, 1 and 0, negative 1. Okay, so these are the two possibilities, the two candidates from this first equation. Let's look at the second equation. Okay, so now if y is equal to 0, then let's see here. If y is equal to 0, then either x is equal to 0 or lambda equals 1. But remember, we also have to satisfy that constraint. So x squared plus 0 squared is equal to 1, which means, we cannot have x equal to 0, right? So lambda equals 1 and x is equal to plus or minus 1. So we've got two possible scenarios here, 1, 0 and negative 1, 0. Okay. Now we need to go back and look at what happens, because remember we had two options here. X is equal to 0 or lambda equals 1. Okay, so now let's go back and look. What if x is not equal to 0? So if x is not equal to 0, then lambda is equal to 1. And if lambda is equal to 1, that means lambda is not equal to 2, so y equals 0. And if y is equal to 0, that means x has to be equal to plus or minus 1. Because remember, we have to satisfy this constraint. So if x is not equal to 0, then x is equal to plus or minus 1. Does that make sense? And just to cover our tracks, let's see what happens if, well, we kind of really don't need to, because we only have two scenarios. Our possible scenarios, either x is equal to 0 or x is not equal to 0. If x is equal to 0, then this is what we get, right? So we've got these 2 points. If x is not equal to 0, then it has to be plus or minus 1. So we've got 1, 0 and negative 1, 0 as candidates, okay? So we actually didn't need to do this. This is wrapped up in that second case, okay? So now we need to do the second part. We found our candidates. We've got 4. 0, 1, 0, negative 1, 1, 0, and negative 1, 0. Okay. The function that we're supposed to be maximizing and minimizing is x squared plus 2y squared. So I'm actually going to make a little chart. And I'm going to say, what is the output? Remember, f of xy is equal to x squared plus 2y squared. Okay, so in this situation, we will have f of 0, 1 will be 0 squared plus 2 times 1 squared, which is just going to be equal to 2. So that'll be 2. That'll be 2. 1, 0, that's going to be 1. And that'll be 1. So our the max of f is 2. And the min of f is 1. This is subject to, this is for all points on the circle x squared plus y squared equals 1. I think we have a little picture here. So here's the idea. Our picture, for us, our candidates were 0, our candidates were, so that's 1, 0, right? And then here, 0, 1. And then we also had the negative values back here, right? 0, negative 1. And for these points, 1, 0 is sent to the min, and this is sent to the max, right? So, and this is the max on, right? So of all these points on the circle, where are they mapped? The largest value, they're all mapped in between 1 and 2, right? The largest value is going to be 2. The smallest value is 1.